Nixtamalization is one of the most sophisticated food processing technologies ever developed, and it emerged not from laboratories, but from lived experience in Mesoamerican cultures that depended on corn as a dietary cornerstone. At first glance, soaking and cooking corn in lime water may seem like a simple culinary step, yet chemically and nutritionally, it transforms maize in ways that modern nutrition science now recognizes as profound. From a positive analytical perspective, nixtamalization is not merely a cultural tradition. It is a biologically intelligent process that turns corn into a nutritionally complete, safe, and metabolically supportive staple. At the chemical level, nixtamalization involves cooking dried corn kernels in an alkaline solution, traditionally made with calcium hydroxide derived from limestone or wood ash. The alkaline environment alters the structure of the corn kernel in several beneficial ways. It breaks down hemicellulose in the cell walls, loosening the hull and making the kernels easier to grind and digest. More importantly, it changes the chemical bonds that trap niacin or vitamin B3 within the corn matrix. In untreated corn, niacin is largely bound and unavailable for absorption. Lime treatment releases this niacin into a free, bioavailable form, allowing the body to use it effectively. This single transformation explains why societies that relied on nixtamalized corn avoided pellagra, a devastating niacin deficiency disease, while populations that adopted corn without this processing suffered widespread deficiency. Nixtamalization also enriches corn with calcium. Calcium from the lime solution diffuses into the kernels, significantly increasing calcium content in tortillas and other corn-based foods. This added calcium supports bone health, muscle function, and nerve signaling, especially important in diets with limited dairy intake. From a metabolic perspective, the alkaline treatment also modifies starch structure, producing a denser, more cohesive dough that digests more slowly than untreated cornmeal. This contributes to a more stable blood sugar response and sustained energy release, particularly when tortillas are eaten as part of traditional meals with beans, vegetables, and chilies. Another often overlooked benefit of nixtamalization is its role in food safety. Alkaline processing reduces levels of certain mycotoxins, including fumonisins, which can contaminate corn during storage. Lime treatment helps degrade or remove these toxins, lowering exposure, and improving overall food safety. In this way, nixtamalization acts as both a nutritional enhancer and a protective measure, reinforcing the idea that traditional food systems evolved not by chance, but through generations of observation and adaptation. The cultural context of nixtamalization is inseparable from its nutritional value. In Mesoamerican diets, corn was never eaten alone. Tortillas, tamales, and atole were paired with beans, squash, chilies, herbs, and fermented foods, creating meals that balanced amino acids, stabilized blood sugar, and supplied a broad range of micronutrients. Nixtamalized corn provided energy and calcium, beans supplied lysine and fiber, and vegetables contributed vitamins and phytochemicals. This dietary pattern supported large, complex civilizations for centuries, underscoring the resilience of a food system built on thoughtful processing rather than excess refinement. Replicating nixtamalization at home is surprisingly accessible and safe when done with care. Dried field corn, not sweet corn, is required. The kernels are simmered in water with a small amount of food-grade calcium hydroxide, typically about 1% by weight of the corn. After cooking, the corn is allowed to soak for several hours, then thoroughly rinsed to remove excess lime and loosen hulls. The treated corn, now called nixtamal, can be ground into masa using a stone grinder, hand mill, or even a food processor for small batches. Clean water, accurate measurements, and food-grade lime are essential, but beyond that, the process is forgiving and deeply rewarding. Once prepared, masa becomes the foundation for an extraordinary range of foods. Fresh tortillas cooked on a hot griddle showcase the subtle aroma and elasticity that nixtamalization creates. Tamales, thickened with masa and steamed in husks, demonstrate how this process supports structure without refined additives. Even simple masa-based porridges provide a nutrient-dense, easily digestible meal. From a modern health perspective, these foods offer a rare combination of affordability, mineral density, and metabolic steadiness. What makes nixtamalization especially relevant today is how well it aligns with contemporary nutritional priorities. It increases vitamin and mineral bioavailability without fortification, reduces toxin exposure without industrial chemicals, and improves glycemic response without eliminating carbohydrates. It does so while preserving cultural identity, flavor, and culinary pleasure. In an era when many people struggle with nutrient deficiencies despite abundant calories, nixtamalization stands as a reminder that how food is prepared can matter more than how much is eaten. Seen through this lens, nixtamalization is not an ancient curiosity, but a living example of food wisdom that bridges past and present. It demonstrates that traditional knowledge and modern science are not opposing forces, but complementary ways of understanding nourishment. By embracing nixtamalized corn, whether through homemade masa or thoughtfully sourced tortillas, we participate in a lineage of eating that prioritizes nourishment, safety, and sustainability, proving that some of the most effective nutritional innovations are already thousands of years old.